Acting Chemistry. These all videos are promoted by fashionable film city Bollywood movie developers. Now we see the condition for the formation of a covalent bonds. According to Fajan's rule, a covalent linkage is favored with following conditions. First, when the cation or anion is highly charged. Second, when cation is small. And third, when anion is large. Now we see the electronegativity and nature of bonds. The nature of bonds between two atoms A and B depends upon the electronegativity difference between the two atoms. Let's see, if the electronegativity difference E sub A minus E sub B between atom is nearly 1.7 or more than 1.7, then it is mainly ionic. But if it is slightly less than 1.7, then it is nearly 50% ionic, and if it is 1, then it is 20% ionic, and if it is 0, then pure covalent. So let's see some examples. For example, element H, its electronegativity is 2.1, and if molecule HCl is formed, its electronegativity difference is 1. So nature of bond is polar covalent. Again, next element is Na, electronegativity 0.9. In molecule NaCl, En difference is 2.2. So nature of bond is polar. Next element magnesium, its electronegativity is 1.0, and in MgCl2 molecule, En difference, electronegativity difference is 2. So nature of bond is polar. Again, in element Cl, electronegativity 3.1, and if we see in the molecule Cl sub 2, then En difference is 0, so it is fully covalent. So these are some examples for the to check the nature of bonds with electronegativity. Now let's see 2 points. Thus hydrochloric acid is less polar and more covalent. And second, bond length order, that is single bond is greater than double bond, single bond length is greater than double bond length, and double bond length is greater than triple bond length. And bond strength order is triple bond strength is greater than double bond strength, and double bond strength is greater than single bond. Now here we see now the difference between covalent and electrovalent compounds. Before it, but see the characteristic of coordinate compounds. First we see the difference between electrovalent or covalent compounds. So structure property. In ionic bond, the ions always form giant structure. In covalent bond, bonded atoms form both molecular and giant structure. Molecular example for CH sub 4, Cl sub 2, and giant structure is SiO sub 2, diamond. Electrical conductance property. In ionic bond or electrovalent bond, solids are insulators, conduct electricity in fused, molten or aqueous solution. But in covalent bond, insulators in both solid and molten state. Now nature property. Ionic bonds are non-directional, while covalent bonds are directional. Next property, rigidness. Ionic or electrovalent bonds are non-rigid. Bond means molecules here, and covalent bonds or molecules are rigid. Next, solubility. Ionic are usually soluble in polar solvents of high dielectric constant such as water and insoluble in non-polar solvents, while covalent usually soluble in non-polar solvents such as C sub 6, H sub 6, CS sub 2 and Cl sub 4 etc. Next property, melting and boiling point. For ionics it is high and for covalent it is low. Next property, rate of reaction. In ionic bond usually fast since the ions have only to collide, and in covalent usually slow since the reaction generally involves bond breaking and bond making process. Next property, space isomerism. Ionic show no space isomerism, covalent show space isomerism. Next property, electronegativity. In ionic, electronegativity difference is larger, and in covalent, electronegativity difference is less. And next property, IP. In ionic, between elements have low and high IP, and in covalent, between elements have nearly same IP. So these are the difference between electrovalent and covalent bonds. And now we see the next, dipole moment. When a bond is formed between two atoms that differ in electronegativity, there is an accumulation of negative charge on the more electronegative atom, leaving a positive charge on the more electropositive one. The degree of polarity of a molecule is expressed in terms of dipole moment. So first we define the dipole moment. It is defined as the product of the magnitude of the charge and distance between the two center of charge. Mathematically it is given by mu equals to E into L. Here E represents electronic charge and L represents difference between two charges. So dipole moment mu equals to E into L, where E equals to electronic charge equals to 4.8 into 10 to the power minus 10 ESU, or 1.6 into 10 to the power minus 19 coulomb. And L, distance between the two centers of charge, is always in the order of 10 to the power minus 8 centimeter or 10 to the power minus 10 meter. Unit of dipole moment, because mu equals to E into L, so its unit is 4.8 into 10 to the power minus 10 ESU into 10 to the power minus 8 centimeter, or equals to 4.8 into 10 to the power minus 18 ESU into cm, or 4.8 cap d, where 1 cap d equals to 10 to the power minus 18 ESU into centimeter, and it is called dBA. So 1 cap d is equal to dBA, which is equal to 4 now in SI unit, 10 to the power 19 coulomb into 10 to the power minus 10 meter equals to 10 to the power minus 29 coulomb meter. The dipole moment is a vector quantity directed from positive to negative charge.